Howdy, my name is Anthony Flores, and today we'll explore CRISPR, a groundbreaking gene editing tool shaping the future of medicine, agriculture, and genetics. Let's dive into what it is, how it works, and the ethical dilemmas it presents. Just on a side note, when I saw this on the list, I knew this is the one and only thing I wanted to definitely dive in and understand more about. I have prior knowledge of it, and the prior knowledge that I had of it was, just to the extreme, of course, the kind of sci-fi, uh, side of it. And of course, we definitely will be getting into that with our discussion, especially towards the latter half of the presentation. But what is CRISPR? CRISPR is a revolutionary gene editing technology initially discovered in bacteria as a defense mechanism against viruses. Scientists adapted this system for precise DNA modification, making it a powerful tool in medicine, agriculture, and research. Not just one field, so many. However, ethical concerns arise as we push the limits of genetic engineering. And as you can see on the bottom of this slide here, pardon me, I do have a timeline of the events, the major events of what really got the ball rolling. And of course, I do include that on the references page at the end of this presentation. How CRISPR works. Here's how CRISPR really functions. A guide RNA directs the Cas9 enzyme to a specific DNA sequence. Cas9 acts like molecular scissors, if you may, cutting the DNA at the targeted site. Cells then repair the break, and scientists can then modify the gene, remove it, or insert a new one. It's absolutely fascinating. It it seems like it's it, I guess you would could call it a technology in itself. It's absolutely fascinating with the when you think about the extremes and you think about the next 15 to 20 years. Um, because we're in our infancy. If you're looking back at that timeline, uh, we are in our infancy with understanding this, and I'm just fascinated with it. All right, medicine. CRISPR in medicine. CRISPR can potentially correct genetic disorders like sickle cell anemia and cystic fibrosis. It's also being explored in cancer treatments to improve immunotherapy. It could prevent hereditary diseases in the future, but concerns remain about unintended mutations and the ethical implications of altering human DNA. Uh, you know, it's that question. The implications of altering DNA. We'll get into that with the ethical considerations, but it it's a philosophical question. It really is. CRISPR in agriculture. CRISPR enhances crops by making them resistant to pests, droughts, and diseases, reducing reliance on pesticides. It also can improve food's nutritional value. However, concerns about GMOs and their long-term ecological effects remain. How much modification is too much? And as a young lad, I used to really think GMOs were the worst for you. They would give you all these types of cancers without any kind of real evidence. I thought that, and just going through these two courses of yours, professor, and just kind of with my own research, you realize that everything is genetically modified. for the longevity, just like in our discussion posts that we had in a particular week, just like for the longevity, for the size, for the yield. Um, if you really try and stray away from everything that's genetically modified and just eat purely organic, is that a viable diet for you? For oneself, can you live off that? And I surmise that you can't. But yeah, absolutely fascinating. CRISPR is not only in biological gene editing, it's in agriculture as well. Of course, this is, you know, the the meat and potatoes of the whole thing. And this is when it gets into the weeds a little bit, but I found it absolutely fascinating. I don't proclaim to, understand this 1,000%, but the more that I grasp, the more that I'm I'm absolutely fascinated with it. I have no other words. It's probably why I keep repeating myself, but I'll go ahead and read what I have here. All right, CRISPR and gene therapy. CRISPR opens the door for gene therapy, offering personalized treatments based on genetic profiles. However, the debate between germ, germline editing, that's heritable changes, and somatic cell editing, that's non-hereditary changes, raises ethical concerns. Should we edit embryos? And if so, where do we draw the line? And of course, that brings us to, you know, what we've kind of been hinting at all. Well, before we go forward, oh, never mind. I was gonna try and go back to, point out the image that I had there, but let's just keep it moving. Of course, that brings us to ethical considerations. The big questions that shape the debate on gene editing today is who should decide how CRISPR is used? Should we allow designer babies or restrict edits to medical necessity? One or the other. How should it be? And who's going to be the arbitrator for where that ball lands? Uh, what kind of decision is that going to be? And if America's doing one thing, is China going to be doing something that's different? Um, what if modified organisms disrupt ecosystems? In terms of agriculture, in terms of biological life. When we're talking about the most extreme side of this, and we add on another 15, 20 years of this. Um, Policies differ worldwide, with some countries banning human embryo editing, while others continue research. Going back to that America China thing, it's just absolutely fascinating to think about where all of this can end up, and land. And of course, that with that, there are risks and limitations. CRISPR, isn't perfect, and we're in our infancy of understanding this technology. Some of the risks include off-target mutations that cause unintended health effects, unknown long-term consequences of gene editing. We have no idea, the long-term effects of this. The cost barriers, which would widen healthcare and inequality. Um, you know, is this technology going to be easily accessible for somebody that's making minimum wage, or is it just going to further the inequality healthcare gap that we already see today? Um, in my writing class, we were talking about this. Um, those who are wealthier, on, on on average, the data shows that they are healthier. They're in actuality, wealth equals health. and not in the way that the quirky way that many want you to believe. If you have more money, on average, you are a healthier individual, and so it just goes into that argument of that conversation. And of course, these concerns highlight the need for careful regulation before widespread use. Again, who's going to be that body? Who's going to be that party? And not even political party, but just that party of individuals that, regulate this. The future of CRISPR. Scientists are refining CRISPR to make it safer and more precise. Potential future applications include disease prevention, bioengineering, and sustainability efforts. However, public debate and regulation will determine its role in society. The question is, how should we responsibly shape this technology?